Okay, good morning, guys. Namaste. All right, this is the slide, the Google slides on section 26.5, which is the expanding universe. So I just wanted to go through these with you guys. Make sure you guys are taking notes just like you would in class, and you have these things in your notebook. Okay, so moving on. Okay, so this is the last part, and this is the question is about how do we know how the universe started, and here's the story behind that. All right, there's this guy right here named Edwin Hubble. Okay, who is a famous American astronomer. Why is he famous? Because um, he figured out how we know that what or how the universe started. And in other words, he's the guy who came up with the theory of the Big Bang, which again, when I use the word theory, remember when I taught you guys, when we say theory in science, that doesn't mean that, oh, it's just a theory. No, there's a lot of evidence that the universe started with this event called the Big Bang. And he was a guy who kind of figured it out. Okay. And he did it about 100 years ago. Okay. So here's what he saw. Now, hopefully you watched the other video I have on spectral lines. This is a good slide to show you what they are. Remember I said there are these black lines that are caused by when the rainbow of light, when all the colors of light from a star pass through a gas. Okay, and so this, for example, these are the absorption lines or the spectral lines. And I used spectral lines, but the book might call them absorption lines. So you want to write that down, that spectral lines are the same thing as absorption lines. Because essentially, when you block out light, you're absorbing it. So the hydrogen gas that is in the sun absorbs some of the light from the core, and it makes these black lines. Now, if you take a look, let's look at this line right here that the cursor is on. If you look at it and you go straight down, now this is the light from a series of galaxies that is very far away from us. Right, 1 billion light years, it says. But if you take a look at this green line, from the light coming off those galaxies, the light coming off those galaxies, that green line is not straight down there. In other words, the lines don't match up, if you can see that. Each line is shifted. And what end of the rainbow is it shifted towards? It's shifted towards the red end of the rainbow. So we say that this effect, we call this effect a red shift. Now, if you remember when we did, and go back to your notes because you all took notes on waves, that light is a wave, and this is lower frequency, red is lower frequency, and purple or violet is higher frequency. So you can see that these lines or this spectrum of light coming off of these galaxies that are 1 billion light years away is shifted towards the red. Well, what does that mean? Well, that's a Doppler effect. And if you go back to your notes on Doppler effect, and remember we watched several videos on this, that's that, where if an object is moving and it's giving off waves, that they're scrunched up. The waves are scrunched up in front of the object as it's moving, and they're stretched out behind it. So what's happening is the light coming off of these galaxies 1 billion light years away is stretched out. This is the equivalent of that Doppler effect going, so that means that these things are going away from us. These galaxies are going away from us. Red shifted means that the object giving off the light is moving away from you. And the more it's shifted, the more or the faster it's moving away from you. Now, this is relevant. Why? Well, because when we look, what Hubble discovered is that all of the galaxies, wherever he pointed his telescope, any galaxy that he looked at, and there are billions of galaxies, any galaxy that he looked at is moving away from us. And it looks like that we're in the aftermath, as the last bullet said, of this huge explosion. Like the universe started and then did that. And all the particles, which would be the galaxies, all right, are moving away from each other. And what that means that if the galaxies are moving away from each other, then if you track them earlier in time, okay, then if they're over here now and they're moving away, then earlier in time they must have been here. And then earlier in time, 1,000 years ago, they must have been here. And then 1,000,000 years ago, they were here. And then so on. And it looks like they came from a common starting point. And that's how he came up with the theory of the Big Bang, that the universe started with this massive event called a Big Bang. And I'll let you take notes on that when, on your own time. I know I'm going a little fast, but okay. All right. So here's just the notes on that. All right. And I'll let you take this down in your notebook. But when we track it back, given the various speeds that the galaxies are moving away from each other, when we kind of track that back in time, that puts it, the origin of the universe, as near as we can estimate in the year, in the current year, is 13.7 billion years ago, is when this event called a Big Bang happened. Okay. And remember, a billion is 1,000 1 millions. So it's obviously a very long time ago. Okay. The other, and I'm going to try and explain this with this slide, the other piece of evidence that we have. So the first piece of evidence that we have that a Big Bang happened is that all of the galaxies are redshifted and are moving away from each other. The second piece of evidence that we have is this. Okay, you take a look at this piece of metal here, and you can tell that this piece of metal is hot. Why? Because it's glowing. When things get hot, they start to glow. The wood in a fire, a campfire, the wood stove in your house, when you burn it, okay, initially it turns to carbon, and that carbon, the black stuff, the ash, and that carbon glows. It gives off light. When things are hot, they try and give off the release or cool down and release their energy by glowing. Now, they do this in a specific way. When something starts to glow, it glows red. When something gets hotter, it glows more intensely, and it starts to glow more up the Roy G. Biv spectrum and starts to glow orange and yellow. And you know that an object that is like yellow hot is hotter than an object that is red hot. And objects that are very hot are white hot, which means that they're giving off all of the colors of the rainbow all at once, which would be something like the sun. Okay. Now this works backwards. When a white hot object starts to cool down, it goes down the rainbow, and so it starts out as like white light, and then it goes, as it cools down, it becomes more bluish greenish light, and then as it cools down, more yellowish light, and then as it cools down, more reddish light. And then you could even go further. Remember, we studied the spectrum. Beyond red is infrared. Okay. Well, what we know, what Hubble found out, is that when he pointed his telescope, or his radio telescope, in all directions, you found these radio waves that were all over the universe. And what are those things? That's the universe still glowing from the Big Bang. The universe started out very, very hot when it was created, when it started, when the Big Bang happened, and it's been cooling down ever since. And remember, when objects cool, they give off light, but they give off different colors of light as they cool down. So there's this evidence called background radiation, which is all over the universe, and it's wherever we point our radio telescopes, we see it. And what it is the remaining heat from the Big Bang that's still in the universe with us today. Okay. And in other words, the universe is still glowing from the Big Bang. And we call this glow background radiation. Okay. So the two pieces of evidence you need to know: one, all the galaxies are redshifted and are moving away. And two, the other piece of evidence you need to know is that the universe is still glowing, and we call the glowing background radiation. Okay. Okay, this is just a slide showing how the universe started out as a small point and then has been expanding ever since. Now, this is a tough concept because to teach, because the reality is when we think of a Big Bang, we think of an explosion. The universe didn't explode into existence. It didn't work that way. What happened was it's weirder than that. First there was nothing, absolutely nothing. There was no space. An explosion implies that there's empty space and then like something explodes into that empty space. It wasn't like that. Initially, there wasn't even space. Space itself was created with the Big Bang and has been expanding ever since. Time itself, there was no time before the Big Bang. Time was created, at least as far as we know, when the Big Bang happened. So before the Big Bang happened, there was no past, there was no future, there was no present, there was nothing. This is unimaginable nothingness. And then all of a sudden, everything for no particular reason burst into being. Okay. And that's weird, but that's the best we have to date. Okay. So what eventually will happen to the universe? All right. There are two possible things that could happen. One, if the universe might continue to expand and then the gravity, because gravity pulls all objects together, if there's enough mass in the universe, then the gravity of all the mass of the universe combined will eventually slow it down and stop it and then start to bring it back together. And then billions and billions and billions of years from now, you'll get the opposite of a Big Bang. You'll get a big crunch. If there's not enough matter in the universe and there's not enough gravity, then the expansion of the universe will continue to happen forever. And the universe will eventually get colder and colder. Eventually, no more stars will be made. And everything will become and someday, a long time from now, billions of years from now, the very last star that was made will eventually die, burn out, and go cold. And when that happens, the universe is essentially dead. And we would call that, we have a name for that. We call that the heat death of the universe. Right now, most scientists think that this heat death is going to happen, and then this reversal is not. But we still don't have enough numbers and information to know yet. Okay? All right. Day of the Dead is George Romero's third zombie movie. Remember, it started out with Night of the Living Dead, right? And then Dawn. Dawn comes after Night, and then Day. So this is the third zombie movie of George Romero. Make sure you write that down. Okay. Yes, Layla Weathers. Make sure you write that down because I already know how to survive a zombie apocalypse, and I'm not doing this for myself. Okay, so here we go. Okay, I will let you guys go through these questions to ruin your self-esteem and make you feel bad about yourself. Okay, all right, so goal us out.